I was going to talk to you for just a minute about latitude and longitude and see if I could give you a little bit different perspective on what they represent. Back in the old days when people lived in a village and they wanted to go to the next village, they just say take that road and go that way and you'll get to the next town. But as people traveled further, as if they were in London and they traveled to Paris or Brussels or Rome, or if they traveled to China or India, they needed a map to show them which way to go, how far it was, and what points were in between so that they could stay on course as they traveled. And that's relatively easy to do if you're looking at a city or a town or a state or a country. What you do is you just make a two-dimensional representation of that area on a sheet of paper. And then what map makers decided to do was to take that sheet of paper and to draw lines on it so that you could specifically designate where places were. So if you take a blank piece of paper and you draw lines that go from side to side, we call those row lines. So if you draw a line from one side of the page to the other, those create rows. And if you draw lines on the sheet of paper from top to bottom, those create columns, the column lines, as we call them in English. And if you take a piece of paper and you draw rows and columns on it, you get what's called a grid. And a grid is a network of lines that cross each other, forming a series of squares and rectangles. And if you create a grid for a map so that you can define a specific point on the map. So if you want to find this point right here, you count over the number of columns, 1, 2, 3, 4, 5, 6, and then you count down the number of rows, 1, 2, 3, 4, and it gets you to a very specific spot on a map so that you don't have to look all over the map, so you can tell where you are, so you can tell distances. Now, if you look at a modern map that's displayed as a two-dimensional structure, what you'll see is that there are grid lines on the map. So if you live in Southern California, in Santa Ana, and I wanted to know where Santa Ana was, I'd turn to a map of Southern California, and Kitty would say, well, you need to look at the grid lines and you need to count over 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 column lines, and draw a line up on those columns. And then you need to count up 5 rows from the bottom left, and that's 1, 2, 3, 4, 5. And if you draw a line where those 2 points intersect, you come to a town called Santa Ana, California. Now, I live in a place called Pueblo, Colorado, and rather than looking all over the map of Colorado to tell Kitty where I live, I tell her to count across the bottom in the column lines, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 columns, and I ask her to count up 5, 1, 2, 3, 4, 5. And so if I put a row line, and this is the row line here, at 5 up from the bottom, and I put the column line 14 over from the left side, and it comes to a town in Colorado called Pueblo, Colorado, and you can specifically find it on this map. Well, drawing a map of a small area is easy because you can take a small area and you can splay it out, and there's a top corner and a bottom corner, and you can draw grid lines on it. It becomes much more difficult to do that same thing with a ball or a sphere. A sphere is nothing but a ball, and there are no edges to create the grid lines. Now, let me define a word here for you. The grid, remember, is a network of lines that crosses each other to form a series of squares or rectangle. The second word I want to define is arbitrary. And arbitrary is a decision based on personal choice rather than for any reason or system. The reason my name is Harvey is because my mother chose to name me Harvey. No specific reason. She could have named me Bill or Frank or Joe or Bob or Louis or anything else, but arbitrarily she called me Harvey, and then everybody else agreed to call me Harvey. And we're going to come back to that word arbitrary a couple of times. So if I wanted to draw grid lines on a structure like this, I'd need a starting point. I need something that told you where to start. And so if you have a structure like a ball, trying to tell you which one of those holes in this ball is the one I want you to go to becomes difficult. One of the things about the Earth that kind of simplifies this is the fact that the Earth rotates on its axis. And it rotates always in the same direction. It has for 4 billion years. It always rotates from west to east. So if you take an imaginary line and draw that line from one side of the Earth through the exact center of the Earth to the other side, and around that line the Earth seems to rotate, you'd have something that looks like this. And so if the Earth was rotating this way, then this line, imaginary line that goes from one side of the Earth to the other. Now the Earth doesn't rotate this way. It doesn't rotate side to side. It rotates in this direction. It always rotates in this direction. And as long as it's in existence, it'll rotate in that direction. And arbitrarily, since the Earth rotates that way, if you stick your right hand on the Earth, your thumb points north, and that's called north just because somebody arbitrarily decided to call it north. And this point where the Earth is pierced by this imaginary line is called the pole. This is one pole, and this is the other pole. And because this line is above the midpoint, this is called North Pole, and this is called the South Pole. And that becomes important because if you take the Earth spinning on its axis like that, and you draw a point that is equidistant, the same distance from the North Pole, from here to the North Pole as it is from here, and you draw that line all the way around the Earth, that line is called the equator. And the equator is important because it helps define points on the Earth. And if you draw a line at the equator, and then you draw lines that are equidistant from the equator, so if this is the equator right here, and you draw another line above it that's 69 miles north, and then another one that's 69 miles north of that, then you draw these lines of what are called latitude. Now, on a flat map, they'd be called rows because they grow across the page. But arbitrarily, just somebody made the decision that they were going to draw 90 lines from the equator to the pole. And because of the distance that represents, those lines are 69 miles apart. And rather than calling them 69-mile apart lines, they're called degrees. And they're called degrees of latitude. So the starting point is the equator, which is equidistant from the two poles. It's a line that's, and then if you draw a line that's 60, you draw 90 lines from the equator to the pole up, those are degrees of latitude. Now, we need to draw column lines on here also. And so if we drew a line from one pole to the other pole through the equator, it'd be a line like this. And so that would be a column line, except when you talk about a globe, a column line is called a degree of longitude. And if we drew lines at the equator, and we drew arbitrarily, just somebody decided we're going to draw 360 of these around, again, these would be 69 miles apart, and each 69 degree segment would be called 1 degree of longitude. Now, they're only 69 degrees apart at the equator. Up here near the poles are not. But longitude at the equator are 69 degrees. Latitude is always 69 degrees apart from the previous degree of latitude. And so if you arbitrarily decide to draw 360 of these degrees of these around, then you get lines that create rows and columns on a globe, and these are called lines of latitude and lines of longitude. Now, the equator is easy to determine because it's equidistant. But how do you decide which one of these lines, of these 360 lines, is going to be the starting point for longitude? And arbitrarily, meaning that just a group of people got together and decided and everybody's agreed to agree to it, the where they decided to start measuring degrees of longitude was through a city called Greenwich, England, and we could go into that sometimes later. But that was decided that would be the 0 degree of longitude, and it's called the prime degree of longitude. And the other word for longitude is meridian. Meridian and longitude are similar, and in a different video I talked about what the meridian is. And so the prime longitude runs through Greenwich, England, and the prime degree of latitude runs through the equator. And that's how you take a sphere and put rows and columns on it. But rather than calling the English word rows and column, the rows are called latitude and the columns are called longitude. And it was arbitrarily decided that there would be 360 degrees around, and that each degree of latitude would be 69 degrees above the one below it, and they'd all be parallel going from the equator to the North Pole.